Hi, welcome to today's video. We're going to be talking a little bit about how we would classify elements. So, why in the world, first of all, would we want to classify elements? Well, the reason we want to classify, and we classify everything in nature, this is something that human beings do all the time, is because we want to be able to make groups and predict, make generalizations about these particular substances or members of a group, whether it's a type of animal, a type of plant, a particular nationality. We do all these things all the time, and sometimes that may not be great. But when we talk about it in terms of science, in terms of chemistry, for example, it is really useful to be able to classify elements, because that way we can predict some of their chemical reactions, we can predict their behavior without necessarily having to do hundreds of experiments, one for each one of the elements that we know in the periodic table. So, before we actually get to talk about the classification, the most important classification of elements that we have, which is the periodic table, we want to see some of the other ways that we can classify those elements. And perhaps the simplest way that we can see for that is classifying matter by its physical state of matter, i.e. whether it's a gas, a solid, or a liquid. Alright? Now, if we do that, we may find that it's a little bit less than satisfying. Why? Well, let's see. To begin with, alright, there are 11 elements that are gas: hydrogen, nitrogen, oxygen, fluorine, chlorine, and all of the noble gases: helium, neon, argon, krypton, xenon, and radon. Alright, there are only 2 elements that are liquid at room temperature: mercury and bromine. All the rest are solid. So as you may imagine, 13 against basically 100 other elements, not great for classifying and getting us to predict some properties. Nonetheless, we can talk a little bit about the properties of these different states of matter. So let's go ahead and look at that for a moment. Alright? If we have a liquid, a gas, or a solid, they're going to have different properties depending on the density, how easily it is to compress, how strong the interactions between their molecules are. And so let's talk a little bit about that. If we start with a gas, right over here. Alright? Well, what we'll find is that gases have very low density. That's because their particles are really far apart from each other. Because their particles are very far from each other, they can actually change volume. You can compress them. If you get the molecules and you put them in a smaller container, you can press them together because there's so much space between the molecules that it is not that difficult to do. Similarly, you can change the shape of the molecule because not of the molecule, but of the container, and the gas will change shape with the container because, again, you have a lot of space for those molecules to move. And the main reason for that is that a gas has very low or very weak intermolecular forces. The intermolecular forces, IMFs, are the forces that keep particles close together. If you heat it up, because you need to put some more energy to have the same substance in the gas phase, what's going to happen, it's going to break or make weaker those interactions because the molecules are moving so fast that it doesn't seem like they're going to be having a lot of effect on the gas molecules. Alright? A liquid instead has stronger IMFs because the IMFs are more in contact, and so it's going to have a relatively high density. It's going to have little free space in between the molecules, and so therefore it's going to have a fixed volume. It's very difficult to compress a liquid. Right, so the volume is not going to change much, so we tend to talk about it as a fixed volume. But because the intermolecular forces are relatively weak, the molecules are allowed to move past one another, and they can change their shape to fit whatever container you put them in. Alright? Finally, we've got solids. Solids have very, very strong intermolecular forces, and that keeps them in a very organized fashion. Alright? So that's going to make them very, very dense. is also because they're so organized and those intermolecular forces are keeping the molecules from moving past one another, they are going to have a fixed volume and a fixed shape. So before, the molecules could rearrange because the intermolecular forces were too strong. In a solid, because they are so strong, it sets very particular shapes, and a solid itself will not rearrange to the volume of the container. You can break a solid to small pieces, but still the actual solid itself, each particle will not change its shape. Let's just look a little bit more at this drawing over here. I don't know what that little thing there is, but we can see again how we got the arrangement, the nice crystalline lattice, which is called, that is the solid, all right? Then we got a more disorganized form, which is the liquid, still quite dense, and then the molecules are further apart in the gas phase. All right. Now, if we talk about gas, liquid, and solid, we know that we can move, any substance can be any of those particular three states of matter. We're going to talk about a fourth state of matter in just a moment, which is at the bottom. We'll talk about that in a bit. But if we have a solid and we put heat into it, well, it's going to melt and it's going to become a liquid. So that process is called melting, or is called liquefaction. Okay? Melting is more than enough for our work. If a liquid then gains more energy and becomes a gas, that method is called vaporization, all right, or evaporation. Vaporization perhaps being a little bit better, or you could even call it boiling. All right, that works quite nicely. We have a gas, we cool it down, we make it back into a liquid. We call that condensation. If we take that liquid and we cool it further, all right, we call that crystallization or solidification or freezing. There doesn't have to be some fancy word. Freezing works just as well, because that's what we're doing. We're going from something that is liquid to something that is solid. It stops moving as much, and that's why you've frozen the motion of the particles. The one thing that we normally don't talk about is what happens when we go from solid to gas. If we add heat to certain solids, they will go directly into the gas phase, and that is called sublimation. The reverse, going from gas directly to the solid phase, is called deposition. And you may not realize that, but you actually see sublimation happening at home. If you have ice or even ice cream in the freezer for too long and you open the cap, you'll notice that some crystals have formed. It's because the water, the ice in the ice cream has actually become gas and then reformed, redeposited as nice little crystals of ice at the top of the ice cream container. That is an example of both sublimation and deposition happening in your refrigerator. All right. Now, some of you may be aware that there is actually a fourth state of matter, which we call plasma. The state of matter called plasma is when an atom loses all of its electrons. All right. And so we're going to ionize the atom, and it's going to become then a naked nucleus, and that is called plasma. And when it regains its electrons, then it goes back to the gas phase. All right. We don't tend to talk about plasma that much here on Earth, because in nature it doesn't occur on Earth. It occurs in stars, right? But here we don't see that much. We make it artificially. It's great. We have it for our TV, certain TVs. We have it for doing experiments. But overall, it doesn't have much influence in our lives. Okay, so now there's a second way we can classify matter, and that could be it classifying elements into metals or nonmetals. All right, and if we look at the periodic table, all right, and I'm going to move here to show you about that. So, if we look at the periodic table, we can actually see that there is a line that divides, all right, where metals and nonmetals are, and that line goes right between these orange elements here. All right, and it's because it divides metals to one side, nonmetals to the other side, and the elements that are by that line are called semimetals or metalloids. Okay? So there are very few elements that are nonmetals. This over here on this side, only these green ones. All the rest, including the ones down here in the rare earth groups, are actually metals. Okay? Hydrogen is not a metal, but all the other ones over here, the green ones over here, are nonmetals. All the blue ones and these purple ones are metals, and these ones in orange are what we call the semi-metals. So again, not a great classification, but it's a little bit better for chemistry because we can start talking about some of those properties. And so let's look at what are the properties of metals. Okay? Metals have metallic luster. You've seen that. They are malleable, meaning that you can actually pound them and bend them into sheets. All right? They're ductile. Ductile means that you can pull them into long wires. Okay? They're excellent electrical conductors, and they conduct heat very well, so they're thermal conductors. And the reason why they can do all of these things is that they have loosely held electrons. All right? The loosely held electrons are going to allow all of the above properties. In addition, most metals react with acids to release hydrogen gas. All right, and so that's one way that we can test whether something is a metal or not, but also we can test it by electrical conductivity, thermal conductivity. Nonmetals, on the other hand, are dull. Some of them are dull. Some of them have non-metallic luster, so they're bright. I mean, a diamond is bright, but you wouldn't confuse the luster of a diamond with metallic luster. It's a very different type of luster. If you actually try to pound them or to squeeze them out, all right, they're actually going to break, so they're brittle. All right, and nonmetals instead are actually very good thermal and electrical insulators, so they are poor conductors of heat and electricity. All right, and that is because they have very tightly held valence electrons. The nucleus holds those electrons very tightly in, and so they don't get to move that much. You don't want to lose electrons. Metals want to lose electrons. Nonmetals want to keep them there. And they tend not to react with acids, so they will not produce hydrogen if you put a nonmetal with the acid. Okay, those are the big things that I want you to think for this video. So your question to work out is, what other ways do you think we could classify matter? All right, what other ways could we classify the elements that could be interesting? All right, think of 3 ways. It's okay if you can't get gorgeous, wonderful ways, but try to think of 3 ways that you could do this. All right? Until next time, bye-bye.